process times, the vessel types used, and also the characteristics of the vessels. So we have the sailing speeds, for example, fuel consumptions in different modes, their capacities, mobilization times, etc. For our base study, we used a database to simulate the weather. In our base study, we used some information from the Danish Coastal Authority, and our base study covers a wind farm similar to Hornsweth 1, consisting of 80 wind turbines, 1 substation, 1 met mast, and it's located about 20 kilometers offshore of the Danish coast. So the parameters, as I said, were some sort of pity because literally everything was somehow classified as confidential. Therefore, we had to do plenty of assumptions which were discussed in our project and last but not least classified as acceptable. So anyways, these parameters are set as variables in our simulation so they can be easily swapped. So if you got more precise information, feel free to hand them to me so we get more realistic results. But yeah, it's up to you. So let's take a look at the outputs. Yeah, what you can see here, or what we can see here, is the comparison of the offshore runtime. Our base study took about 571 days of offshore operations, and it was quite good. So perhaps we didn't, or we choose a scenario or base study where the people who planned it spent many thought on. Anyways, the other scenarios all have significantly longer times, but it's also due to the nature that for the erection of Hornsweth 1, they used more than 1 erection vessel, and also they combined both logistical systems. So they did a good job. Coming to the coast, it becomes more interesting. So our base study revealed costs of about 160 million just for offshore operations, and it's just the pendulum bunny ear and the pendulum star configuration were able to reduce the costs in this simulation model. As I said, it's hardly dependent on the parameters, so of course it can be adjusted. So anyway, the changes of up to, or the savings of up to 5% are somehow, I would say, warmly welcomed. I mean, it's money. Who doesn't like money? And also in the context of the DecomTools vessel, which wasn't presented yet, but it was a prototype some colleagues of me developed, and we added their specifications to the simulation model and tried to see, okay, how much could a newer vessel with more advanced technique possibly reduce. So, considering the CO2 emissions, it was quite interesting that we were able to reduce the CO2 emissions of offshore operations just by changing the dismantling strategy by up to 32% in our simulation model, and that's quite good, I would say. So the pendulum bunny ear and the pendulum star nearly produced 1/3 less of CO2 than our base study, and even the part-by-part removal, which took way longer, as we have seen 2 slides ago, was able to reduce the CO2 emissions of up to 18%. And also the DecomTools vessel did a quite good job by reducing the CO2 emissions by 35%. So perhaps it's a call to look at newer propulsion systems, or let's say more CO2-friendly systems. To sum it all up, simulations in general can give a really good overview about supply chains and may even offer potential for improvements. Still, it must be noted that everything rises or falls with the databases. So the more realistic the data basic is, the more realistic the results become. Or to say straight, shitty input delivers shitty output. Also, I would like to point out that there's no solution fitting all. It is way too dependent on the variety and complexity of the project itself. But anyways, the appropriate logistic arrangement are and will be essential for such kind of projects. Besides the logistical simulations, we did some other cool stuff, such as a prototype design, which we call the DECOM Tools vessel, or the virtual reality modeling. Unfortunately, the presentation time didn't allow us to take a closer look on the virtual reality modeling, but if you're interested, just hit me up so we can have a closer look on the on our exhibition stand about it. With that being said, over and out.
Are there any questions?
You were talking about hazardous materials. How do you find out about hazardous materials which are in materials, hidden or whatever? Do you do that on documentation or sampling, or how do you know?
Perhaps we have to identify it, you have to look at the documentation. But as I said, most data is quite confidential, so we had to somehow say, okay, there will be hazardous materials, but we can't classify them further, so, or at least we couldn't classify them further in this simulation model.
Any more questions?
Mark, for the nice presentation. Could you remind us in your simulation results what you refer to as the base study? What approach that has been taken there?
Actually, for the base study, as I said, they mixed up the logistical systems and dismantling strategies. So, for example, they installed the foundations in the feeder system. And for the erection of the wind turbine topsides, they used the pendulum system, but they also used more than one vessel. So, yeah.
Thank you. Mark, I just wanted to know, many people can do simulations and with different software and so on. In your experience, what was the most difficult part of carrying out this simulation, and what will you say for people that want to do this kind of simulation in the future? What is the lesson that they can learn from your work?
The most difficult part was to gather the information. As I said, it's crucial. It's a crucial factor to get all the information to create a realistic digital twin. And my personal advice would be collect enough validate data and don't rush with the programming.
Any more questions? Now it's over.
Thank you.
In the next presentation, we listen to the CEO and CCO of the Port of Grenna, who will share their ideas on this subject from the perspective of the port. Here are Hendrik Carstensens and Thijs Gisselbeck.
Thank you very much. It should be a specific PowerPoint from Port of Grenna, I hope.
Sorry, but you also have a presentation
Yeah.
to load up?
Yeah. Lucky. There we are. Thank you. Thank you for letting us having an introduction of our port. A very short introduction by myself. Henrik Carstensen as named. I've been at the CEO at the port since 2015, and before that a long career within the shipping industry. Very shortly, our history in this project, we have been there from the beginning as a port, but also Thijs and myself has been joining the project when we started it back in September 2018. And of course, what we will tell you about today is related to what we have heard many times already, logistics, but also the challenges we look into the future for land, for space and facilities. This is an overview of our port. As you can see, fairly big port with 1.4 million square meters. We had a lot of different facilities with warehouses, etc., row ramps, etc. But yeah, it's been said many times, we also into the future need to look how we can develop our port to be secure that we have all the place needed, both for decommissioning of windmills but also of new windmill projects. We have a short video here telling hopefully everything about Port of Grenaa, so hopefully the technique will work. Can we have some more sound on it, please?
Grenaa is Denmark's most central deep-water port, the ideal gateway to Northern Europe and the rest of the world. The gate to the Kattegat. As one of Denmark's largest industry and commercial ports, we effectively handle goods from land to sea. We create growth and prosperity as we load, unload, and industrially store to the benefit of companies and society. Our vision is global, and we believe that a sustainable world must be built collectively. We find new green ways and save energy and resources in cooperation with our customers, the community, companies, and the world. We are experts in offshore wind and aim to become the test platform for the green energy of the future. That's how we promote the growth of a green world. Always close with a long horizon. With our feet on the key and the sustainable development goals tucked under our arms. The Port of Grenaa is much more than a traditional industrial and commercial port. We work for a dynamic and vibrant local community. We boost tourism when we create alliances across the Kattegat and promote experiences, business, and innovation. We are the Port of Grenaa. We stand as a professional port at the ready for our partners, from the local ferry to the global need. We create solutions for the future, and we have the will to succeed together with you.
Finally, before I give the word to Thijs, this is our 8 core segments, and I know Thijs will focus on especially 3 of them, of course, related to the wind, the energy and the innovation, of course, and the recycling and the waste management. And with that, I'll give you this one, Thijs.
Yeah, in general, with our strategy, the idea is that we have these 8 core segments, and if the customer or the use of the port fits into more of our strategy legs, then we can add more value to it. So, for instance, wind, recycling, bulk, if we're looking at decommissioning, that makes very much sense for us. My name is Thijs. And I come also with a background in the shipping industry. I am the commercial responsible for most of our focus areas, and I come with the background also from wind, from MSI Vestas, so I also fairly know about transportation and logistics and handling of that part of the industry. Wind is extremely important for us. Looking back, we have a track record of doing installation projects, both bottom fixed but also floating. And looking in the future, we will also see a huge development within wind. And when we say wind, it's related to offshore wind. If it is an onshore wind project, we call it actually a project instead, because there is a difference in how we act as a port. Recycling waste management, the other segment that relates very much to the decommissioning operations, are very huge and in development at our port. We do a lot of steel scrapping, but also a lot of other materials, and we see a growing industry also for used materials for the biogas industry and so on. It, as it was also told before by Andres, it needs a lot of environmental licenses to do this kind of work, so it's not every port that can do it due to their location close by neighborhood areas and so on, but due to our location and our experience, we are capable of having such a segment at our port. We have a master plan that both try to focus on wind and decommissioning of wind, but also the development of power to X and industries that needs a lot of space. So we are both working at the quay side, but also working with industrial areas nearby the port, together with the municipality. And that could, for instance, be recycling, but also production of wind and so on. I'll tell you about 3 cases from Grenaa. We come out of a long history of ship recycling with small and medium-sized vessels. And when we started this project, our idea was to look at ship recycling and see if we could benefit with the supply chain of ship recycling and move some of the knowledge towards wind recycling. They started their, it's a company called Fornes, they started their main activity on the recycling part of and scrapping part of the ship. But today they have actually turned the value into their stockyard, because 70 to 90% of their income today is actually selling of used materials to the world industry of vessels, and their main what they live on is of course also their knowledge about what kind of vessels are there in the world that can use this type of engine and find the customers. So what we have been looking at is how does the wind industry works? How could we connect a potential stockyard of used wind turbine material to the market? Because it works totally different from the ship recycling. But it's a good case because the hierarchy of recycling is starting at a higher scale, and resale and refurbishment of the components is much better to the environment and the overall recycling cost. Another case that I will talk about is a case where we actually refurbished 8 that was onshore turbines from Germany, where we gathered together with a company called Eurowind in Denmark all the turbine parts from around Europe. They were sent to Grenaa because of our facilities and knowledge about handling of turbine cargo, and then they refurbished a lot of the gearboxes and all that, and painted new blades to have a lifetime extension of the turbines in Scotland. So this is also one of the things that relates to the ship recycling industry of today, that reuse of the product is actually a good case. And for the V80 turbine, I think the production number is 22,000 of that turbine. So if we could just recycle or reuse 10% of that to another market, then it actually makes very much sense. The last one is Stena recycling at our port. We are used to handle around 400,000 tons of steel scrap a year, and their ambition is to have zero waste in their systems. Today they focus very much on metals, but in the future we will also see plastics and composites and other things that relates more to the wind industry and cables and so on. But we're used to handle both components at a certain size, but also small components in bulk. So we try to have a logistic supply chain close by the port, so we are able to not to transport the components too much from it arrives till it ends either as a new product, new used product, or a recycled product. But our challenge and opportunity is the new offshore wind industry. Looking ahead, this is the map of the development of offshore wind just in Kattegat, where we see this is our home market. It's about 15 to 16 gigawatt, and I would say on a monthly basis there will come new projects in the region, starting from 2025, and looking at both the new industry of wind, of erecting new turbines and pre-assembly, and also being able to deliver port infrastructures for the recycling industry is a challenge. So what we do both on a Danish port basis, but also European ports, is to try to reach out to the politicians in Denmark, but also in the EU, to emphasize that it's actually very important that we get some hubs, port hubs, that maybe some can do both, but we at least need to figure out how to do it the smartest way, because port infrastructure will be a limited factor in the future. Therefore, we also look at port expansion plans that fulfills both the new turbines but also the used turbines. So we are looking at how to levelize the projects, because the project could be both coming in and out at the same time, but how do we actually operate it? So this has a high focus for us both right now but also in the future. That was everything from our side.
I think there are some questions. Any questions for these gentlemen? Yes. I hand it over again.
Thank you. I was thinking about these expansions and the supply chain. Do you see from your partners that they are also has planned to expand? For example, in the case of Ostend, they are already quite big. They want to be bigger.
Yeah, they will. That is, of course, a fortunate situation for us that most of our customers within the 8 segments is actually having expansion plans at our port. But to levelize that in between and to prioritize it and to deliver the right infrastructure at the right time is a challenge right now, because one thing is that we have an ambition of a port expansion strategy both in water and in hinterland, but the environmental licenses or the process to get the building permits in Denmark is extremely difficult. Both, and we can look at it, it's not very much different from being a port and then doing an offshore wind project, because it's the same kind of licenses we need. And right now that timeline is just too long. So we have fantastic ambition, and the politicians are very good at announcing what we want to reach, but the supply chain is challenged due to its project based. You can of course build a vessel to install or decommissioning things, and you can move that around where the projects will be in the future, but you can't move the port. So in case in 10 years, if the plan of 15 gigawatts is finished in 10 years, what do we then do with the port infrastructure which we have built maybe right now or in the near future at a relatively high building price because of the market right now? So it is, we need to see it in a bigger perspective where the politicians also are part of taking some of the risks. Thank you.
Any more questions?
Thank you guys for your presentation. I was wondering from your point of view, what makes the most sense if we look to, let's say, within 10 years, there will be new wind farms being installed while older ones will be dismantled. Port of Grena, everything should or could be done from that port. Does it then make sense to dismantle an offshore wind farm as fast as possible, dump between brackets everything in the port so that you can repower the site as fast as possible? Or would it be better, from your point of view, to take your time so that it's like in a more gradual fashion?
In the talks we have had with developers and installation vessel companies is that we should see the decommissioning in more or less the same way as the pre-assembly is today. So we need to deliver a lot of port infrastructure, a lot of square meters at a certain point. We will need to be the flexible point in between decommissioning part offshore and a steady production onshore, because production needs a steady flow. It can't change their production in a fast way. So we need to be that flexible part, because onshore or offshore, they don't have the capacity to keep them there. So we see that we need to deliver a lot of square meters, and it is practically the same as pre-assembly. Of course, the turbine parts are not that fragile, but square meter wise, it will be an issue.
We've talked earlier about floating turbines, floating port.
You can take that one as well.
It's not right now in our strategy, I would say. If they start with the floating solar on a big scale, then we can look at floating ports afterwards. Of course, it could make sense to look at if they can have some kind of big, enormous barges that could be some of the flexible path between. But looking at the market today and the investment cost that would have, then I would say it would only start after the market is rising. And if we see an installation that will only start maybe in the mid-30s or end 30s, where the market is big enough, but it is a possibility.
Okay.
Last question. One last question, thank you. Unfolding, I think I saw the thrust part from Stisa with the ports.
Yes.
One question I would like to ask to you, because one of the big challenges for you guys is, of course, making the investments for the expansion. Could you indicate us the time frame? Like, how long will it take for you guys to make the decision, get the money, get the works executed, and how do you then factor that in your strategic planning?
As Thijs was informing about, of course we have the plans. Right now the market is not so good for building materials. It's double off if you compare it with 2 years ago. So right now we are in a balance to find the right time. We hope as soon the market goes back to normal that we can make a more specific business case. We are not as most of the ports in Denmark. We are a limited company, so meaning we cannot finance via our municipality. We need to go out on the private market. So our hope is 1-2 years from now we can hopefully make a very solid business case and then get our financial partners to agree on this and then start the expansion. So my guess would be 2-3 years from now. Hopefully we can do some expansion. But the blue stippled area is so we can do that faster because that's owned by the municipality, and we have already some dialogue with them, even to rent or to buy that area. So land, hinterland, can go quicker, but if we want to expand our keys and areas related to that, I think 2 to 3 years. Yeah.
Thank you, gentlemen. From the port of Grenna, we go to the port of Ostend, where Jan Allehaert is commercial director.
Good afternoon. A lot of what has been said this morning now comes together to the port of Ostend also, and I will try to explain you how we will be ready for the decommissioning, what will come up in the future. But mind you, we are struggling with exactly the same problems as Port of Grenna. As just said, we need space in order to be able to do the installation, but also the decommissioning and to be ready. We need a lot of space. First of all, about the port of Ostend itself, we got involved in the offshore industry some 15 years ago, and as we now see, 2.2 gigawatt is being installed in front of the Belgian coast, and what we see now is 800 people directly employed only in the maintenance or operational in our port. 15 years ago there was nobody, now 800 people already. And we hope that once the decommissioning will come up, some more people, some more direct employment will be there in our port. So this is a map of the Belgian waters. It's not so big as Danish, German or Netherlands or the UK waters. We only have a small surface, but we try to do our best as Belgians then to have everything on that small area. And you can see 2.2 gigawatt has been installed of offshore wind industry to the Dutch border. We do not only maintain those wind farms, but we also do maintain out of our port the Borselen wind farms just on the other side of the border. And 3.6 gigawatt has been decided by the Belgian government, Princess Elizabeth Park as it has been called, and that will be installed, we hope, starting 2027, 2028, something like that. So we need to be ready as a port, so we need also extra space. But these are the installed wind parks close to Ostend, just to give you that figure. So 2.2 gigawatt, meaning almost 400 turbines has been installed, meaning also an investment of 8 billion euros. It's a lot. And as you can see, the first wind farms were built with 3 megawatts Vestas, Northwind. The last windmills and wind turbines that have been installed are 9.5 megawatt. And they all become bigger and bigger. Now they are speaking about 12, even 15 megawatts. So not only the turbines become bigger, but also the blades become bigger. So you need more space in order to be able to install that. And what was told to us, and we also see it with all the concession agreements we have with Vestas, Siemens and all the other players, we have concession agreements for the maintenance of those wind farms of 15-20 years. So the first wind farms were built 2008, 2009, in front of the Belgian coast. So we were thinking, okay, 2023, what we are now, we will start with the decommissioning, but what we see is there is a lifetime extension. So we see now, and we think now, that the first wind mills will be decommissioned in 2030. But we need to be ready as a port in order to have the wind farms decommissioned in our port. The Belgian wind farms, I was talking about the offshore winds, but we also have a lot of onshore winds. And that's a graphic that has already been shown to you this morning. So 74% is up and running. 18% is the permit is granted and will be built in the near future. 6% is under construction, and 2% needs to be decommissioned already, but that's for the onshore industry, and I'm only talking about the Belgian market for the time being. Then we made a study during DECOM Tools in order to see what kind of manufacturers are building those wind farms. And you can see there has already been some mergers between some manufacturers. So we have Siemens and Gamesa went together to Siemens Gamesa Renewable Energy. But the two most important players, manufacturers, are DECOM onshore and Vestas onshore and offshore. And if we then have a look at the time frame, then you can see on the blue for the offshore. So the first offshore wind farm has been built 2009, and the last has been built in 2020. So then you can try to count what is the lifetime and when the decommissioning has to be started up. What is a wind turbine made of? That's also something that has been projected this morning. But we have took two wind mills, the Vestas 90 and the DECOM 92, in order to see what kind of composites, what kind of material is inside such a wind turbine. And you can see most of the components is steel and concrete. A little bit of aluminium, copper and polymer. Polymers are the composite materials for the blades. If you have a closer look at it, you can see it's steel and mostly concrete is the main part of those wind mills. A little bit aluminium, copper and polymer. For most of these components, we can recycle them and we can use them in the circular economy. There's only one big problem, and that's the polymers of the blades. A lot of institutions, a lot of organizations are looking at it in order to find a solution for it. There have already been some solutions, but economically it's not viable for the time being in order to recycle it totally and to put it again on the market. But if we go again to the Belgian market, we see 500 wind farms are operational in Belgium, representing 2,000 operating turbines, and that gives an amount of 750 tons of steel, 6,500 tons of aluminium, 9,000 tons of copper, 40,000 tons of polymers, and almost 2 million tons of concrete. And with those figures, you can go to the market, you can go to the industry and say, hey guys, we have that kind of material coming up. Are you interested in not only recycle that, but also perhaps do it on a circular way so that you reuse it again in industry markets. So then we looked at the infrastructure. The only terminal we have is 15 hectares big, as you can see it. And we also have extension plans. We want to extend another 8 hectares in the open sea, actually just behind the breakwaters, in order to be ready, or at least to be a little bit ready for the new parks that needs to come and needs to be installed in front of our coast. But that is just for the installation. Then the decommissioning still needs to come up, so we need actually also a lot of space. But in the meantime, a lot of companies have already established themselves in our inner port. To name a few of them, you can see them. But also, for example, you have a stand over here of John Cockerill. John Cockerill is active in the maintenance of the wind farms, the windmills, and they are also very active now in the decommissioning. They want to play a crucial role in it. They are not mentioned here on my slide, but they want to play a crucial role in it. They have a big industry in the south of Belgium, and so we are looking together with them in order to transport them, the recycled components, via barge towards the south of Belgium. This was, in short, my presentation. Thank you.
Thank you. Now, we close this third part of the conference with a presentation of Björn Wittek, who is Managing Director of Renus Offshore Logistics since 2014. They're headquartered in Germany, and he presents the logistical problem from the point of view of a shipping company, forwarder. Within the two ports, we have the most important actors that are relevant in this logistical process, so he completes the puzzle. He will identify the challenges and the expectations. He's joining us digitally.
Good afternoon, everyone. I'm happy to be part of it and having the opportunity to talk and present this afternoon. Our scope is at the end of the day the role of a logistics operator, both on and offshore. We are part of a pretty large industry group, very much known to many of you likely. Us as Renus Logistics, one of the global logistics operators. Remondes, our sister company, active in the field of recycling, life cycle, water management, industrial services, wind turbine services, plant management, scrapping. Our sister company, Zaria, working in a pretty similar field with a different focus, more on the production focus. And our fourth large pillar, the Transdev public transport group of companies. Altogether family-owned and always asked by our family and management to try to present not only single solutions but total concepts for total service solutions. And that's why we think we are quite qualified for the tasks ahead of us, decommissioning of offshore wind parks in all its tasks. Certainly the line of scrapping. TSR is one of the largest scrap recycling companies in Europe, working on a multitude of hubs, inland, imports, at job sites, not only ferrous materials but non-ferrous, having specified cable recycling facilities which are operated part jointly with copper producers and the cable operators, down to electrical stuff recycling, in principle the whole supply chain requirements up and down needed for the scrapping and dismantling of all metals, and other sister companies working in the field of fluid recycling, fluid disposal, composite disposals. Then we have us as Renus as the second large integrated part of it as a logistics operator, operating a variety of seaports, many more inland ports, a total of about 50 port locations in Europe nowadays, project logistics operators, vessel operators, and us as dedicated entity in the group for offshore services. We understand as Renus Offshore our scope in principle from port to the offshore installation and back, rendering all logistical service needed, shipping of equipment and people in and out, making sure that sub-projects such as buoy deployment, campaign, business are running smoothly, supply of offshore CCUs, and then working in port, cable handling, cable storage, small spare parts, large spare part storage and handling. Everything what is needed to serve wind farm up and down during its life cycle start, up, operation, and later decommissioning as well. If we take a look on logistical perspective of decommissioning, it's easy to say we have in principle no clue what is going to happen. We only know we brought the wind farms out, they are operating there, at one point we have to bring them in. How we are going to do that one is probably one of the magic questions we have to find a proper answer on. What is quite clear, it will happen at one point of time. The exact year is anyone's guess. I'm of the opinion it will happen rather later than sooner. The overall market currently points towards that one. We still have a lack of experience in decommissioning offshore wind. These small pilot projects were just that, pilot projects with in principle no real reference to real world in terms of sizes of complexity. Dismantling large onshore turbines is probably closer to reality what we have seen offshore so far. Decommissioning will be complex. We are not talking about one turbine design. We're talking about a number of designs. We're talking about very different water depths, water soils, frameworks for disposal, even on European level down to the local ones. How it's going to be addressed from a commercial point of view is from our very likely decision taken by the individual companies, some of them the large European players, and with kind of public shareholdings, they will certainly have to tender for that one. That means we are looking at European tender level quite clearly. Others will make it pretty much a typical commercial decision. Technology from very small 3 megawatt Vestas or Siemens up to much larger, depending on the time frame we're looking at. One thing is clear, it's going to be expensive. How expensive, nobody will really know. But that's being the main challenge. We need to be very efficient and we need to be very cost sensitive. Because whatever we are going to spend there reduces at the end of the day the profit our clients, the wind farm owners, will have in their pocket. And one thing is for sure, the moment you want to touch profits, they get together, they're starting to get anxious. The logistics themselves, at sea, we don't know how they're going to be structured. I've seen ideas from doing it in principle in a complete build-up in a reverse fashion, up to very opportunistic, whenever one turbine fails after a specific age, it's simply dismantled step by step whenever there's an opportunity, a jack-up flying around, having nothing to do, and simply putting it on shore. We will have to work in a very challenging environment with unclear paths ahead. What is probably easier to understand what will be removed. I think everything will be removed except for the scour protection, these stones. Everything else will have to go. For one simple reason, whatever you're going to leave in the area or where the wind farm has been standing is going to disturb you on the next or on the follow-on project. There is no business case and in principle no technical case to reuse cables, to reuse monopiles, to reuse anything, simply because technology has moved forward by quite a margin. It has become much, much bigger. The 15 kV cable was standard 10 years ago. We are now looking at 66 kV cables. We are looking at monopiles now weighing 2,500 tons, and I've even seen pictures or drawings of monopiles as heavy as 4,500 tons. We started off with 400-500 tons. It's clearly not workable to leave an old monopile and put in 15 or 20 megawatt turbine on it. Means everything has to be removed. I think that's the easiest part to look at. The logistics concept, we are looking at backward construction concept. I don't see any other viable opportunity ahead of us, simply because physics will dictate that we're going to remove blades first, then the nacelles, then the tower, and later on the foundation, maybe with cables in between, and very likely as one of the last items, the substation and its foundation. Which in turn means we are looking at very much the same vessel which have been employed for commissioning, mainly in construction, mainly jackups, support vessel. On the cable lay side, I think there are easier ways. We don't necessarily need a full-blown cable laying vessel. There are certain easier ones, especially for a product which will never be reused, which will simply be scrapped. So we don't need to take care about what we are recovering, we just need to recover it one way or the other. Looking forward means that decommissioning will put a very high pressure and strain on an industry segment which will be working on extremely scarce capacities already on a very high cost level. Vessel availability, we all know that one. If everything goes nice, if anything fails, well, we're going to have a problem and need to find a vessel in a market where it's likely nothing can be found at the end of the day. There might be variations that a pontoon is put into it. You keep the jack-up vessel offshore. Then you have lifts offshore, which are not really liked by marine warranty surveyors and vessel owners themselves. There might be variations, but at the end of the day, the moment we are talking about decommissioning, we are looking at construction reverse. One thing which I think hasn't been mentioned really so far is the time slot we are going to have available for the decommissioning. From a commercial perspective, the farm operator will try to run the wind farm as long as anyhow possible to maximize profits. The permit will have pretty clear-cut date until when it has to be handed back, and they will try to push the decommissioning as far to the right as anyhow possible. It means that the logistics concept we need to work from scratch. It means a big focus on availability of equipment, and the question, how are we going to treat risk like vessel window, like vessel equipment and the vessel availability overall. So it's not going to be easy. It's something which will need a lot of focus on during contract negotiations and later on during execution. The logistical task itself, to decommission it, to get everything removed, I think that's something we're getting managed. The turbine part anyway, the foundation part, might be a bit more challenging, but at the end of the day, if there's a problem, there will be a technical solution. Whatever it takes, it might cost a bit more than expected, might bring some technical challenges, but it will work at the end of the day. Bottleneck will clearly be vessel equipment capacity, and if we turn staff and qualified staff as equipment, that's going to be a challenge as well. But it's not going to end there from our point of view. What we are going to have as scarce availability in the vessel market will be the same on the port end. We are looking into a market, not only in Europe, but in principle around the world, where offshore wind is very much on a build out, with many projects coming up, and they are going to grab the port facility capacities in first place, because they are going to pay more than we are going to pay. Issue on that one is cost. We're going to store a monopile removed, let's say 100 meter long, 10 meter wide. For easy calculation, 1,000 square meters, it's going to cost you 6,000 euro per month just to keep it stored on port, if not more, plus all the logistics around that one. If you multiply that one by 80, just because if you move to full wind farm, you're talking about 500,000 of storage cost just for the monopiles on the lower end. This is money the operators, the wind farm operators, won't be willing to spend. So our focus will not only have to be how to remove it fast offshore, our focus as logistics industry will be how to store it in the most efficient way in port, and certainly the next step, how to get rid of it in the next step. So it's quite clear, as little storage facility as possible is required, the quickest possible cargo turnover is required, but there are more factors. Transport frames. Are transport frames still available, or do we need to remanufacture them? I know that a lot of them have been scrapped because there was no need for them. And we all of a sudden need to rebuild, let's say, 20 or 40 transport frames for ourselves because we need to do some safe handling. It's not that somebody's earning money, it's the wind farm operators who will have to spend a lot of money just to get the frames back in place. Cranes, SPMT, so there are a lot of cost factors. The port facilities we will have to use until the same ones we are using for offshore wind at the moment as well. We have been looking the shore sites in principle up and down for the past years, and are still doing that one. But it's not visible that there will be many additional ports coming in who are able to serve large jack-ups operating in the decommissioning market. So we are looking at the same ports as the installation process, which will bring a very high conflict in itself. That is probably one of the keys we are looking at. Getting the recycling industry, or in first stage, probably not even talking about the recycling, rather talking about the scrapping part of the recycling industry, into shape. We need to be able to work on industrial scale recycling, which means we have no chance to work days and weeks or probably even months on making chopping up a monopile and put it into transportable frames. We are talking about days maximum just to keep the productivity of the port area available. Steel, like monopile, transition piece, and tower, that's likely the easy part. Cables maybe as well. On a nacelle, we're talking about everything you can find on that one, from fluids to electrical machinery to composites around it. So it's going to take quite a while to have them cleaned up and shocked. And then rotor blades. Our biggest challenge up and down, how to do that one. So it means we need to focus not only on port capacity, on vessel capacity, but we need to focus on how are we going to get productivity in the recycling and scrapping chain, because that's going to be one of the main keys from our point of view to be really able to manage decommissioning, in principle decommissioning logistics as well, in a proper way and find probably not the right word, but balance between costs and productivity. It's going to cost the operator anyway, but we need to make sure that the cost block is as limited as possible. That was it in a very quick run through. So, anyone has questions, certainly available to share my point of view.
Are there any questions? No? Okay. Thank you, Björn. Thank you very much for your presentation. Now, before talking, ladies and gentlemen, about recycling concepts, the last topic of this conference, we're taking a coffee break. See you in half an hour.
That should help our head.
It's very good.
En het zit op zich wel goed in elkaar. Exact. Ik weet niet of het zelf dat ik is omdat ik ga doen, maar de rest niet eens weet van elkaar. Dan vraag ik mij af.
Want het is niet zo moeilijk. Ja, eigenlijk als je zegt van kijk, ik wil het nog installeren. Ja.
Thanks for
We don't have the example.
Yes. Okay. Yeah, and which microphone can I use? Because I will probably walk. And I need to stay on the stage, or no? You don't need to. Okay. If you want to go exploring to the crowd. Is it echt regie in transitie? Yeah, echt, but you can say also ECHD, and then it's in our few stages ECHD. But I would say that I'm representing BLUEBRIDGE because that's BLUEBRIDGE in this DECOM Tools project. But is it too complicated? No, well, you worked on the pilot projects. Yeah. About that, yeah, you can say that I'm from BLUEBRIDGE. That's also fine. Okay. Yeah.
Please.
Yeah.
I was just So
I will start. Yes, always some curveballs.
I like it.
And especially at the end of the program, you need to have something different.
Hi.
You like more?
It was clear.
I know I like you. Yeah. But I'm not sure whether I like Alexander. Oh, that's wrong.
Alexander is also very likable.
Dutch directness.
Hold on with that.
If I smile charmingly, it's okay, isn't it?
It's no bad thing losing.
Oh, okay, yeah.
Very tough.
Yeah. And you have something to, like a point horizon.
It's an ambition, it's a goal to reach those targets. Or yes. Long lifelong learning.
Yeah.
I wonder about the happened to remember off the top of your head how much offshore wind 6 years ago. 3, 2, 1, go.
I would say 6.5.
And now we are at
around 30. There's a little bit more, of course.
Yeah.
31 installed as of last year. Don't quote me on the 6 or 7.5. Yeah, no, but I mean, we on average, let's track things. We on average had 3 gigawatts per year. 6 at 8. Then we're at around 8. That's all. Yeah, around that. So 3 gigawatts per year is good. There's 1 year very much more. 1 year.
Yeah, I was just thinking because it was basically designed 6 years ago. And it was about offshore decommissioning. So advanced compared to where we were. Yeah. Nobody cares. Yeah, it's fine. Yeah, when we started.
Exactly.
Yeah.
Everybody wants to do their
So that we don't have to maximize strategy.
No. One of the key points, so in all of those areas, underpinning that to electrify our initial like 75%, 60% hydrogen. With a lot more. The goal is to reach that.
Okay, it's time for the last topic of this conference, recycling concepts. Now, first speaker is an absolute expert in the field of wind turbine recycling. She's project manager at ECHT. She's taken on the development of various recycling concepts in her project, especially the pyrolysis. She will speak from her experience with the pilot project and her experience with waste legislation. Here is for you Nina Vinen-Kali.
So welcome from my side. One thing that I would like to start with is actually that DECOM Tools project was designed basically 6 years ago. 6 years ago, someone talking about offshore decommissioning and blade recycling was something that not that many people cared about, to be honest. But I also want to show you something, what is happening at the industry. So here's a couple of slides that I want you to look at and think about. Recycling, recycling, recycling. So this is where the narrative is at the moment when we talk about wind turbine blades. But actually, why are we talking about recycling when there is so much more other circular strategies available? And this is something like a narrative that we need to change, because when we talk about recycling, it actually has an effect also on the policy level. As long as we talk about recycling, that's the only solution that they think is available. So that is the reason why I want to talk about also why recycling is problematic as a word, trying to change the narrative on that. But also, of course, the pilot project that we did as part of the DecomTools project. So we will talk a little bit about the higher level problem here, but also the pilot project and the pilot pyrolysis process that we used for the blades during the project. But I would definitely want to inspire you as academics and industrial partners to change the narrative. Should we talk about waste? Or should we talk about secondary raw materials? Should we talk about recycling? Or should we talk about circular strategies? So what is actually the problem, the larger scale problem here? EU Waste Directive. And then comparing it to all the circular and sustainability targets that we have at the moment. But at the end of the day, the biggest effect is on what EU Waste Directive actually says, and that is the problem on the circular strategies, because it's very difficult to meet at the same time the circularity targets, but at the same time we are bounded by the definitions of the EU Waste Directive. What I mean here, don't worry, we're not going to go through the whole Waste Directive, just a couple of examples. So waste means any substance or object which the holder discards or intends or is required to discard. And this is also the problem, of course, for the ports, because immediately when the turbines are coming to the ports, it's considered as a waste, and that means that you need all these special permits and licenses and so on. And what does the recycling mean? It means any recovery operation by which waste materials are reprocessed into products, materials, or substances, whether for the original or other purposes, and yada, yada, yada. So most of the time when we are talking about circular strategies, but we actually use the words recycling, we are not talking about the correct topic. So that is the reason why words matter and what you use in your own communication. At the same time, we have the waste hierarchy, which is actually very much outdated compared to the strategies which are already available here. So we are talking about only a couple of different options, and recycling is actually not so very high in this map. It's just above the recovery. And we have so many other options, which we will hear some of them also today after my presentation.
It's very difficult to get the end of waste status because it is very much based on if there is a market and it is commonly used. And this is not the case when we talk about blades. There is not that many companies or organizations screaming, we want to get the blades. No, it's really other way around. We are trying to figure out what can we do with the blades. And this is now the problem on the policy side. And there needs to be technical requirements that are met in this new purpose. So all these are actually hindering our opportunities to move towards the real circular economy. Short conclusion. The current waste law doesn't really support the circularity targets. And that is really the overlaying and the most important challenge that we are facing at the moment in order to accelerate the circular economy. And at the same time, we need to change the narrative because this has an effect also on the political understanding and the decision making. We also should start thinking like, okay, when we do talk about the recycling in its correct definition, then there is different types of recycling with different impacts. But at the moment, they are all considered one and the same thing. But there's also a difference. Do we recycle in Europe? Or do we recycle in somewhere else? And then we start thinking about, okay, what is the material impact in here? Because at the same time, we want the wind to be made in Europe, but also there's an opportunity to use these raw materials in Europe so that they stay in Europe, and we don't lose these valuable secondary raw materials to the other markets. So it's also, maybe we should start thinking the impact instead of the technology that we are using. So there is a more holistic approach needed in order to look into this in a more better way, and maybe the waste hierarchy isn't sufficient anymore. Now the second part of the presentation. We did a pyrolysis pilot project inside the DECOM Tools project. We received some wind turbine blade pieces and used a batch pyrolysis process, which made it possible for us to extract the pyrolysis oil and the fibers of the blades from these pieces of blades. And the fibers we further processed into a cleaner, nice fibers, naturally not in the same condition as a virgin fiber, but anyhow good quality. These pieces of blades had both carbon and glass fiber in them, and they were pre-cut in different pieces, but relatively big pieces, so not the laboratory scale testing, and the lengths were somewhere between 40 and 120 centimeters. And in total, we did 2 rounds of testing with 35 kilos and 44 kilos. Who has experienced that you have a plan for your project and then it doesn't work out? We experienced that also. So we had a plan of using a continuous process, which in general is more effective than running your process up and down. But then there was a technical issue, which we have also experienced today a couple of times. It happens, and then you need to pivot to some other direction. And that was the reason why we had to change the original plan of a continuous process and go to a batch process in order to get forward. These cartridges where we put the materials were about 50 times 200 centimeters, and we processed in this pyrolysis process, we used about 550 degrees, and the process time was about 90 minutes. So what does pyrolysis process actually mean? Most of the time, if you're not, if you don't have anything to do with chemical engineering, people think that it's burning, some kind of burning. Yes, there is heat, but the process is closed. So in this right side picture, you can see that the blades are already put into the reactor, and it's closed with this cap. And all the gases will be collected, so there is no burning, so there is no emissions coming out of this process, but all the gases are collected. So there is no oxygen present, so there is no burning. The materials are gasified, and these gases are further cooled down, which means that it's converted into pyrolysis oil. Some gases still come from the process, but those are collected. All the materials that do not react in this temperature that I mentioned, 550 degrees, they stay in this cartridge. So in practice, we received about 16 liters of pyrolysis oil from this process, and we further did a laboratory analysis on what was the content. And all the phenols were further converted to BTX. BTX it's a chemical compound which are normally gotten from the crude oil. So the whole point here was that we can actually substitute crude oil with this process. And that is very interesting, of course, that we could make further plastics and other chemicals, other raw materials from this BTX instead of using crude oil. And that is also the way to capture the carbon so that it's not going to any kind of incineration. It is also possible to crack this BTX further so that it's possible to crack the part of so-called heavies, the 68%, into further BTX, so the yield of this pyrolysis oil would be even higher. The positive side about this approach is that the market exists. So normally BTX, like I mentioned, is gotten from the crude oil, and well, there is plenty of market for crude oil and the chemicals that come from that. So just to give you an impression about the pyrolysis oil and the fibers that were first filled with char, and so they are very black and dirty, but you can see that the fibers can be extracted from each other already because all the resin has been processed into the oil. So we had 57 kilos of these fibers and residue, and we further treated with the heat in order to make them more pure. On the top, you see some pieces of carbon fiber-based parts, and on the bottom you see the glass fiber-based parts, and you can see that they are it's possible to treat them clean and nice. But this will never be a substitute to a new blade. It's not the same quality anymore. But there is developments for different type of new products where these carbon fibers and the glass fibers can be used. Conclusion on the pilot: it is potential to substitute virgin fossil raw materials, so the crude oil. Average 27% of the total mass of these blades were converted into pyrolysis oil, which, if you think about it, it's actually quite good conversion rate because that's approximately the weight of the resin in the blades. So about 70% are the fibers. The yield of the BTX is possible to increase through the process optimization. Now we had to do 2 steps during the process, and of course it would be better to do it in one step. So it could be optimized so that all this pyrolysis process and the treatment of the fibers would be in one place instead of with 3 different partners. So, in order to improve the circular economy on the side of wind industry, there is definitely still a conflict between waste directive and the circularity targets, which is hindering. We should change the narrative from recycling to circular strategies in order to really make sure that we take into account all the strategies which actually start from the design phase and not from the end-of-life phase. There is a huge opportunity to steer these circular strategies through tender criteria in the new farms. This we have seen happening already, at least in France. There was already tender criteria where there needed to be a circular strategy for the blades. And we also know that in the Netherlands, the next tender will be include circular tender criteria. We just don't know yet in which form. So we are very much looking forward to March and April when the government should release this information. This hierarchical approach regarding waste, the waste hierarchy might not be sufficient anymore. So there is definitely an opportunity for the policy makers to actually change the waste directive to facilitate the actual targets which we have on the circular economy side. One of the opportunities here is having more transparency and a holistic approach so that it becomes more objective, also analyzing what are the impacts of the strategies that we choose. Because at this moment, it's sometimes very difficult to say which circular strategy is better, because it always depends on the system boundaries that you choose when choosing the strategy. In order that we can actually learn from each other, we should be able to provide as an industry more data to the academics who have maybe more resources and time to make all kinds of assessments and analysis on that data. And we have heard also in this conference many times that the data and information is missing in order to provide more reliable results. So that is something that we can do as an industry. And that is from my side. Thank you.
Thank you. Oh, please stay, please stay. Are there any questions? Yes.
I would be curious, in pyrolysis, for how much tonnage can you solve, I mean, the industry problem? Like, what is your intention? So that's question number one. Like, what are you targeting at, generally, and as a solution? And the second thing is, how do you clean the fibers of the tar? So that would be very interesting, because that's a quite intensive process. If you could, explain that a little bit.
Okay, the first question about capacity targets. I would turn this question other way around, which I tend to do often. I would first look at what is needed, and what, depending on in which region you are, there are different opportunities for different strategies to be chosen. So if we are in a region where there is a lot of chemical industry and possibilities to crack this BTX further, and there's a proper volumes of blades and or other composites, then it makes sense to go to the strategy of pyrolysis. But it's not a silver bullet for every region, because you need to, especially if you use a continuous process, you need to have a continuous feedstock. So it really depends on which region you are, that if the pyrolysis process is the smart choice. Second question about the fibers and purifying them. So in here we used just oven treatment, higher temperature that did burn the char out for a shorter time. But here we also learned something by doing. Because when we did the oven treatment, we were first really surprised, the fibers are not getting white, what is wrong? We didn't know that those were carbon fibers, so they were supposed to stay black. So again, yeah, we should have marked them somehow better that in the phase when we put it in the batch process. But yeah, live and learn.
More questions? No? Okay, thank you.
Thank you.
Our next speaker is CEO and founder of DECOM. She and her company have the first promising approach of complete material and energetic recovery, which is an extraordinary advance in the field of wind turbine recycling. We welcome here on the stage Claudia Martens.
I had a long travel, so I bring my own water. So well, I can use also stuff. All right. Yes, so we're brand new. Since yesterday, I officially have a new email address, and so that's how brand new we are. No, officially we were founded actually in October, but and we are working on the project already for 3 years. So it's not that we just came out of the closet, and said why. But we thought we are ready now to go public. I have a long track record in the wind industry, and definitely I am responsible on putting a lot of blades out there, in the world. So at 20 years or 22 years when I started, I said, well, what about the blades? Yeah, well, don't worry, Claudia, in 20 years we have a solution. I'm like, uh-huh. So after 10 years I asked again, oh yeah, we're working on it. So, okay, so, there's apparently a lot of energy went into it, but, not so much results for 20 years. So I thought, well, this is an interesting project. So, actually we have a small company. We do green projects and green businesses, which means we help businesses to reach their net zero targets faster. And then on the side, we develop our own projects. One of them is ammonia, one is a flare gas or lean gas turbine, and one of them that we just spun off is Joule Mine. Joule Mine, why Joule Mine? As a joule in terms of energy, and mine in terms of urban mining or waste mining. So that's kind of the intention behind the name. So, and a lot of the slides I will hop over it because we're already late and you in essence know what's on it. So take some of these, I would say beginner slides more as to understand where our thinking came from and why we have a bit of a different approach. So for us, we don't like the word recycling. I don't think it's a sexy word, so we use transformation. And so we are transforming the blades into fibers, hydrogen, and in essence, that goes into like a methanol synthesis. So yeah, this is just a couple of points I want to talk about. You already know about the problem in the market, but here I would really like to discuss a little bit where do we need to think maybe a little bit differently. So you all know that, and I was really surprised to hear that you also focus on, in the process, on the regeneration of the carbonates, because this is really a huge topic, and that is what everybody is forgetting about, apparently. So our approach was really to really take a fully circular approach, and that is basically what we also have in our branding. No? So we want to be regenerative of everything, and every element matters. So it's not good enough to just recycle and extract like one material. And I think where the thinking goes wrong is when we talk about CO2 neutrality. A couple of solutions, they praise themselves and say like, yeah, we recycle and we are CO2 neutral. Okay, but that doesn't mean you're circular. So, or that you have a great solution, or that you have a solution for the whole industry. Maybe it's a niche application, which is fine, but then you're niche. So for us, CO2 neutrality was a given, that had to be, had to be there, but circularity was also a key factor. And so that was one of the guiding principles that we had. So you all know about the problem, I don't have to talk about that. And also about the market, so we can save some time here for you guys and maybe have a discussion later on. So, but there's, contradicting trends. Volume goes up, thank God prices are also going up, at least for us. But there's also a lot of downsides in terms of, disposability. So, and when I, usually talk to other people, it's true, it's in the presence now more and more and more. So you can read it now in big newspapers, with like recycling. So now, let's say, average mom and dad knows about it, right? So a couple of years back, that was basically nothing. So, but now everybody says, oh, this is a problem, this is a problem. Yeah, but what they don't get is like, we're just, it's in the beginning. So there is really large scale is needed. And that is, I think, what everybody is underestimated, what's really coming in terms of volume, and that we need a solution for volume, and not just for a niche. Niche is great for certain applications. There's always, a need for niche applications, but to solve this, well, that needs a bit of a different scale. So you all know this is a typical route. This is how very big companies also in Germany dispose basically blades. They shred it and then it's incinerated in a cement kiln. But we come from a different type of thinking. We are not technology development company in the first case. No? We all have an engineering background, physics background. But we are not like born with a recycling gene, or it's not in our heart. We took it from like a different, angle. And obviously, the composite material is an interesting. The challenge is in the material itself. You all know that. But what we found is everybody is focusing on the fibers, or at least the majority of project is focusing on the fibers only. And that is, I think, where we need to think a bit differently. Unfortunately, animation is still on this one. So, so we all, we dig out the anorganic and the organic part. So the organic part is, the oil or natural gas. That's the C. The C, the carbonates, is the valuable part. And we don't pay any attention to that. So it is quite linear. Obviously, make then those two streams. Then you kind of shred it and it's incinerated, but the value, it's just, you use it thermically, right? So in the end, you're losing all of your resources, right? It's a dead end. It's also a dead end in two ways, because the road is closed. So one of the large cement facilities like Holcim in Germany, they're changing their approach. So they have just won the innovation fund, got big funding, and they're changing it. So if anybody wants to look it up, it's called Oxyfuel from the EU Innovation Fund. It's a great project. And they're going green. So that road is closed. And there's just one more, cement facility in Europe who can actually incinerate. So that road is closed for the big peak it's coming. And in our world, in our thinking, it's not circular, no? That's pretty linear, so there's no circle somewhere in it. Then we have, the approach of, there's a lot of approaches of like downcycling. So for us, that's also a bit with a grain of salt because you make some use of it, but at least that is our opinion. You just push, the problem into the future. And that is not a circular approach. That's maybe CO2 neutral for the moment, but it's not circular. That's at least in our way. Make use of it, but you really don't gain anything back in terms of, the materials. It's a filler material, and then the question always is, how big is that market really? Does it solve the problem? Pyrolysis, we just heard actually everything about it. So I don't have to say much. However, parts of also, the carbonates are lost, some are captured. We also looked at pyrolysis. It's not that we woke up and said like, oh, we're gonna do this. No, we also took a deep dive into pyrolysis. And we're working together with the TU Freiberg, the Berg Academy and Freiberg on gasification and pyrolysis together. And but in essence, for what is coming in terms of tonnages, you cannot scale. So there's a limit of scalability for pyrolysis. And for what's coming in the market, we don't need facilities who can take like 5,000 tons or 2,000 tons or 100 tons or whatever that is, right? We need larger facilities. And there is a technical limit to where you can scale pyrolysis. It has been tried, most of them are not running. So, do I build like 30, 40, 50 facilities around the world? Or do I find, a different solution? So, and just to recap that, I would like to say like why is it so important to capture carbonates? Because we are all going for a decarbonization right now. But the chemical industry, so anything from, even this chair, to like just remember how much plastic is in your life, right? There's definitely options to replace that, with other materials, but we are running out of carbonates. So by all these decarbonization projects, it's like you have a bathtub and then it's overflowing and you shut the tap. Great. But then you use up everything that's in the bathtub. And we thought that's not so smart. Why don't we regenerate what's in the bathtub? Right? Because in the end, we cannot deplete any further resources. So, and if we say like, well, we 100% want to decarbonize, that means you are asking for a society without any chemicals. I would say, good luck. But that's not going to happen very soon. I mean, that's basically 1800 something, no? So we have to find a solution how to close the circles without depleting virgin resources and also to save the carbonates in a smart way. That is basically the approach where we came from. So also on the carbonate side, we need to move basically to like a circular carbon economy. And that also gives us a chance. So one of the project, pyrolysis or gasification, what we do is one option. There's plenty of other options also with organic materials. But it's also an option to basically get independent from imported carbonates, in terms of like oil or, natural gas. So it's also a chance really to think in that way a little bit differently. So what do we do differently? Well, we take basically the shredded material and we have a refined process to separate it. So in the end, we are getting like small fibers. They don't look like big mats, so it's really small fibers that can be used into other products. And we receive the matrix material, which is basically the glue and the resin. So, and in terms of thinking, we thought, okay, what are our must-haves? Because we thought there's a lot of interesting projects in the market. A lot of people have, and smart people, putting a lot of, brain power into it. But there's always a little bit missing, or it's not scalable, or, there's always a little something. So we just defined all our must-haves and said, all materials need to be fully regenerated, recycling only with renewable resources. No downcycling allowed, so no pushing into the future, and needs to be scalable, needs to be CO2 neutral or better, and needs to be economically long-term viable. That's also very important. I mean, we need to have a solution, that also economically makes sense. If, I recycle stuff and I don't have a market for it, or nobody wants to pay for the product, then that doesn't make so much sense in our way. So, how do we do it? Basically, same process, but then we basically, we also have a separation, but then we have like a syngas reactor. So we don't incinerate it, but we gasify it. That's where the latest incineration step is basically missing. That's the difference. We are not incinerating anything. So we are regenerating the carbonates into a syngas, and we are closing the loop. So that means in a syngas or in a plastic, it's always C, H, and O. Right? That's what you get out of it. That's the golden dust. And the CO2 is basically captured as a syngas or as a gas, and it's going back into the refinery for like a methanol synthesis. It's, I think, an absolute illusion that airplanes are going to fly in 10 years, with hydrogen or other materials if you talk about it, but at least you can make the kerosene, for example, green, or you can find other applications. So where do we get the oxygen from? So the oxygen, that is our reaction material in the reactor. So we have a very, very low demand on electricity, like super low, no? So our reaction material is oxygen, and we need a lot of it. So, however, where we picked our location, there's a lot of large electrolyzer projects ongoing. So we can pick basically the waste of the electrolyzer project, that's the oxygen, and put it and use it in our reactor. It's, in the north of Germany, there is a very smart network of companies, and that makes really a lot of sense for the business case because it saves a lot of capex for everybody. That's super sexy. So, so we get basically hydrogen, because that's the H in the syngas. We regenerate all the carbonates back into the refinery. The refinery can also use the hydrogen, but where we're going to settle, there's also a pipeline network. So if we reach a certain grade in terms of cleanliness of the hydrogen, then we can also put it into a pipeline network for like a gas station, right? So it's used as fuel. And the fibers can be used in certain applications. Definitely not going back into the wind blades, but in other applications, the market is still growing. Yeah, so that is basically what we're going to do. These are the key facts of the project. It's roughly 60 million invest, give or take. The capacity is, the maximum capacity would be 55,000 tons a year, one facility. So if you imagine that old turbine blades, they're between 6, 7, 8, maybe a 1.5 is roughly, 10 tons blade. You can scale it up. So this solution is scalable. The interesting thing is that, pyrolysis, there's a limit to where you can scale. For gasifiers, we are like mini, no? With 55,000 tons and like 22,000 tons, right? We're small. We're like, they go like, oh, you wanna build a pilot plant and operate it, right? Because normally, companies who build large gasifiers, they go like 500 megawatt, 1,200 megawatt. So we're like mini, right? But a couple of these gasifiers have been built, they're also operational. One of them is actually NZTU Freiburg, the other one is with RWE. So it is basically state of the art. But yeah, we are shrinking it, so because we don't want to be too big, at least not in the first facility. And so that is basically the key data. So out of that, we roughly get like 4,000 tons of hydrogen. Roughly, 40,000 tons of CO2 that we are regenerating. So where do we settle? The chances are let's say 95% that we will settle in the north of Germany in Heide. There's this big network of already going on called Westküste 100. That is really a really smart setup from the region. So because we need a couple of partners around us. One of them is a refinery. So basically we have a pipeline connection. There is caverns where you can put in the hydrogen for storage, so you don't have to invest and build, you can, in that network, you can actually all use the same infrastructure. And that makes this region so sexy for these type of projects. There's super large scale electrolyzer projects are being built, and we are getting the oxygen basically from the smallest one. Because we have roughly a need of 10,000 tons per year, which is quite substantial. So, but that's like the oxygen of the smallest electrolyzer project. So right now we still have to do, of course, some technical tests and specifications. Patent is basically an application, and we have shown in like a prototype that we can do the separation. But now we want to re-engineer that part a bit differently to make it, to increase the serviceability. So that is what we are currently working on. And we have an investor on board. So we have, out of the 60 million, we have secured equity for 50 million. So that's a good start. And the region definitely they really want the project, which is great. And I think they're going to help us, to find the rest of the money. So, so that's basically the end. Yeah, and in the end, we would like to actually scale, to Spain, to the US, possibly India. So, basically all markets are interested that have been historically large markets. So as of yesterday, this email address is valid, so.
Thank you.
Good. It's interesting to hear all these different views and approaches. Do you have any questions? No questions? No question?
Many thanks for the presentation. You hammered down a lot on scalability.
Yeah.
One question from my side. What type of composite material waste can you take? Can you take it from wind blades? Can you take it from boats? Can you take it from cars? Can you take it from everything?
Definitely wind blades, that's the main objective, no? But we don't want to have carbon fiber in it, so what we really are focusing on is to have like a, let's say, relatively clean material up front, because we want to be very lean in the downstream processes where you have to wash like the syngas and so on. You know, we really want to be clean, so we don't want to have bolts. Is yes, we can take bolts, but then, for example, you know, the coating has to be gone because that is where all, you know, the hazardous, you know, parts are in there. So it depends a bit what material we can take, but we can take definitely production waste. In theory, bolts, bathtubs, whatever, but certain products need pre-treatment.
Questions?
No? Thank you. Thank you.
Now, should we recycle or repurpose? Our next speaker is convinced that repurposing is a good and viable alternative before recycling. She claims recycling can always be done also after a second or a third life of the blades. She's co-founder of the company BLUEBRIDGE, and she develops outdoor furniture, bicycle racks and playgrounds for children from the old blades of wind turbines. Enjoy the presentation of Antonio Boma.
Yes, that's not the first one. No, wait. Yes.
No, that's not.
It's this?
Yeah.
Oh, okay.
I don't know, but I hit several.
It says 135 slides.
Yeah, but that's the whole thing. Yeah. They were hidden. So sorry. It starts.
Okay.
I hope this all works because it says 135 slides and I'm not going to bother you with 135 slides. May I ask before starting, who believes that repurposing blades could be scalable? Well, thank you. I would like to take you from where you probably know us, and which was also in the introduction, and then tell you how we are working on the scalability of the blades and why we are doing it. We all love the blades. They are beautifully, from a technical point of view, they have these very tough materials, and they also embody great craftsmanship next to the technical characteristics. But we also know that at the end of their life that they are deplorably stored somewhere, or cut into pieces, or even go into landfill. And you may recognize us from the very sympathetic design we made in 2007, mind you, which is more than 15 years ago, and it looks exactly the same today. So the architects, our co-founders in BLUEBRIDGE, super-use architects, they thought of the material as something beautiful, which will probably be acknowledged by the industry because they put all their energy in it, and they made something new out of discarded blades. At that time, you can see, I will just scroll through some images of realized designs. At that stage, the super-use architects thought that if they would provide the design technique open source globally, that also globally the other architects and maybe also the demand would come, and that wind turbine blades would be seen as a secondary material to make something beautiful out of it. You've already seen that the performance of carbon emission is very good compared to standard category objects like playgrounds. They perform like 90% better because we do the footprint calculation as well. And what is also very nice, after a year or 10, here in this case the urban city of the municipality of Rotterdam was thought of as being, as needing to be new, and there was a demand for a monument for the LBHDQ community in Rotterdam. And instead of making something new, we proposed to use the blades as a canvas to make it into a monument. And so it happened, and the urban city got a third life. Well, here are some other objects. In the port of Terneuzen, an icon also at the entrance of the port of Terneuzen. We do markers, and so far, and this is the last one at Dutch Design Week in Eindhoven last October, where 350 visitors, well, they didn't all pass by, but a lot of them passed by, and we had over 4,000 children climbing on this boulder blade. There's a blade bench also, and we had over 500 grown-up climbers on the boulder blade. This is all very sympathetic. Here you can see like the mini barrier, we call it. These are the smaller parts of the sound barrier we've presented at Bilbao with Europe. And this can also be used in a mini form in urban areas as a green screen to shut off horizons which are not desirable for the people to look at. So far, we have repurposed 27 blades, and with a good performance. But we thought, well, this is also very sympathetic, but it's not good enough. So we thought to really have impact, we have to scale up. We scaled up in terms of organization. So we were established in the Netherlands. From there we work on Europe. But we also have offices in the US, from Washington and New York, and in China, from Beijing and Shenzhen. And actually we just won a prize in China, which acknowledge our purpose, and that they are very interested not in the designs itself, but in the purpose of the design to have an impact on the waste, especially to avoid blades, discarded blades, to become waste. We are also organizing ourselves in order to become a natural partner in the chain of decommissioning. So now, for decommissioning, it goes to reuse in the original on another turbine, then to the shredder, and then or to the incineration. But we want to, push ourselves before the recycling, because, as Nina said, recycling is something that has to be reframed. And we need to call it circular strategies, because the amount of blades that is coming is so vast, we need all the options. And hopefully from our perspective and from the Earth's perspective, we can phase out or ban incineration because of the high levels of energy it needs. Another thing to scale up is to make bigger designs. This is just an inspiration for a concert temple or a hall in a campus or whatever. You can see there are lots of blades used, but and also like a bus station, which is turned into a transferium or into a mobility hub, and host more than just what is seen here. We are about to realize, finally, the pedestrian bridge in Aalborg. The bridges are something that are also very interesting to invest in. And we also use we have found a use for the root end, where in this case there's a changing room for the swimmers in the community, and on their request a sauna at the other end. But the real impact design, of course, is the blade barrier. The blade barrier can have about 200 blades per kilometer, depending on the blade, of course. And it combines with biodiversity so that the dust from the road is also captured and it is given back as CO2. This is the urban side from the blade barrier, because one of our signature in the design, one of the aspects of our signature in design is that we also want to add social value. So if it is good as a sound barrier for the roadside, and for the people on the urban side, the quietest part is close to the barrier, so that we make into an interesting interesting area. Our strategy is to have a full blade use. So if we have a blade, hopefully we have lots of blades, we will cut it into pieces and use the pieces to, for instance, form the sound barrier. Sometimes a blade is damaged, so not all can be used, or for some design, the bigger parts, the root ends are too big, so we cannot use that either. But our strategy is to make something from the whole blade. Here you can see how this sound barrier is being set up. There's a foundation into the ground, there's a structure, you put the blades on. The blades are cut into several pieces of several heights, up to 6 meters. And then there is going to be a basket with plants in it that have a good quality of CO2 capturing. The height is about 5 to 6 meters, with the smaller parts I also explained can go into urban screens. And the performance, technically, we did a study with the Technical University of Delft. The performance on paper is comparable to that of generic sound barriers. They can be integrated into existing barriers, which is also very nice. And from a bird's eye perspective, you can see our signature again, that you have a two-sided value for the area, and that we can also use other parts of or spare part, or leftover parts for objects in the urban area. So this is all very nice, and so we've been in preparation, we've had some acknowledgement. We won the Impact Pioneer Award from TEDx Amsterdam, we were named Changemaker, we got some national TV coverage, some publicity, very, very nice. We also was participating in a circle track to already plan for the decommissioning of an offshore wind park in the Netherlands from Eneco energy company with all the industry partners. And we were granted support by the national government of the Netherlands to form a circular chain. Because we think that the promise is in the scale. So yes, it has been sympathetic for the past 15 years. But Made was established 1.5 years ago to make the impact, because the momentum is now for the onshore wind parks that are going to be dismantled, and we have to organize into circular regional value change in order to be able to handle the blades coming. What this needs is that we need to go for a paradigm shift in the industry. We need to think differently about recycling. We need to think, and I'm very thankful for Bonina actually to already frame it as circular strategies, and to also give the podium to the repurposing strategies we have. But also, if we keep thinking about the only criterion is that it's economically interesting, then we won't be able to handle it all. We have to take the responsibility as an industry and as people, and with all the different positions we take into the chain. Everybody has to take responsibility as a corporate, but also for the climate and the earth and the future. So if we change this perspective, then we can go into partnerships like we already are talking, and we hope to be able to, around with Europe in Copenhagen, we hope to be able to tell you more about it. But we are in serious talks with the energy companies and blade producers in Italy and in France. And we are also doing that, of course, in the Netherlands, and we are looking into the North European region because of the faster market that's coming there. What do we need? We need to go and form this change in order to be able to plan ahead. Not 3 months, to sell a playground, because that is not our purpose. Our purpose is to assist the wind industry in their end-of-life strategy. So if we plan ahead, we have to know who has the blades that are going to be decommissioned, when they will be decommissioned, in how many there will be decommissioned, which ones can be earmarked as going to repurposing. Some of them will remain spare parts, others will be damaged and have to go to recycling. But there has to be a mix in the decommissioning that is going to be planned, and we need to know which type of blade. And then we, under a non-disclosure agreement, we work with the technical drawings and already design for the region of the decommissioning. So, for instance, in the south of Italy, we are planning like shading and barriers, etc. But in the north, we would need shading, so there we do other designs. And then we would make like a catalog to sell the smaller designs and to do the business development for the very big impact design. But we plan ahead. A circular chain would be something like this. So for the next 10 years, the focus will be on onshore dismantling. And gradually also there will come offshore dismantling, because like the wind park we talked about in the Netherlands, that's can be decommissioned in 2028, so it's not very long. And we form a chain with the dismantling company, with the transport company, either on land, by road or rail, or on sea, by boat. Then it goes to the blade make facility, where also is the urban mining, so the storage, and the transformation by means of the contractor. And we do the stakeholder engagement in order to have the legislation ready to be able to perform, in order to have the wind industry ready to participate, etc., etc. And we do the footprint calculation and, of course, the design, because that is where we started off. And then you take a smaller loop of the object to go into a public space. In a second smaller loop, you could do it like in a, to make another design, and eventually it could go to recycling as yet. Because in the meantime, we appeal to anyone who finances it to also invest money into the development of the recycling industry in order to be able to make this the industry really circular. Because we think that the repurposing strategy is like a linear extension, and to be really circular, you have to make sure that the material ends up as basic material to be put into a world again. And in the meanwhile, we keep it into the loop. The recycling industry can develop further, innovate, and be ready for the amounts that come from the offshore industry. And should it not be ready by that time, we will have the experience to at least have a part of the offshore industry dismantling. And also, what I wanted to add is that we work business to business and business to government. We do not do consumer products. That's a conscious decision we've made, because we want to make the material we reuse. We want to make it traceable. because in that way we can also, work on, and that's also part of the stakeholder engagement strategy, is to see whether we can have like a return policy or something so that the material doesn't end up as waste in the end. In the Netherlands, we formed this circular chain consisting of Business in Wind, a decommissioner. And what is interesting to mention is that Business in Wind is also investing into a facility that they can use while the blades are on transport by water, so that they can use the time that the blades are on the water and avoid that the blades are being transported as waste, because then they are already secondary material. The second one is the design, the super use. I forget to mention the partner in urban mining, which is Vermeer urban mining company. Then the super use for the design, GKB group for the contractor to contract and to transport, and the footprinters for the footprint calculation, and of course me and my partner Jan-Willem from the citizen design to do the stakeholder engagement, the project management, and the business development. I would like to invite you, or maybe not all of you, but those of you who are in our loop to connect to us and to also form regional circular chains in which we can repurpose at least part of the decommissions, the to-be-planned decommissioned blades into bigger impact designs that can add to our urban environments and give them a second or third life. Thank you very much. We have to do this together, and for now, I'm curious to hear who believes that repurposing could be a scalable solution.
Questions?
I was just wondering, how long do you think you could prolong a circular cycle like you mentioned?
Well, we know that like a smaller design as a playground has now been in use for over 15 years, and it's still as new. It only has had a splash of paint twice. So that's very low maintenance and very good quality. We're not sure, but we guarantee at least 30 for one use. But it could be, the material is like very tough. So it could also be 100 years. We say it's more dependent on fashion than on the technical life span of the material.
Thank you.
Any more questions? Okay, thank you.
Thank you.
Yeah, around two. Thank you. Our last speaker is the founder of Upcycling Plastic. They focus on difficult to recycle plastic and textile waste streams, and they also come up with recycling opportunities for wind turbine blades. From the materials from these blades, it's possible to make insulation. I hear. Here is Jan-Jaap Vollmer.
Thank you. I think I have about 35 slides. So
I didn't use all my 135.
no, it's okay. I have 7 slides. I try to keep it short. I'm not very specialized actually in wind turbine blades. It's more or less what Nina said to me. I was asked about a year ago, like, can you use wind turbine blades in your products? And we were thinking, and it was actually at a football match in Groningen. You don't want to see FC Groningen play football these days, but it was there with people from DECOM North and from Seaports Groningen, and we were talking a little bit about recycling of wind turbine blades. And we saw some possibilities, and one of these people talked to somebody from the organization here, so I was invited to SBAC a couple of months ago to tell a little bit about these ideas. I'm from Uppect, which is a company that is recycling the unrecyclable. And that seems impossible, of course, but we try to do it. And we are actually recycling especially plastic waste, polymers. Mixed polymers, which are too difficult to sort from each other, or fishing nets, other difficult to recycle plastics, running shoes we can also handle, unshredded, unsorted and unwashed. And we put it into a machine which we call the unwaster, and it goes through the unwaster, then it goes through an extrusion process into a mold, and we produce construction materials out of it. And that's normally from plastic. We can take contamination up to 15–20%, that's no problem. And I think it was Mark earlier who said that shit in means shit out. We always say, we also take shit in, but we make something better out of it. So it looks like shit, but it's not shit anymore. It's a homogeneous and rather consistent material. It's also a recyclable material. And the former speakers talked a lot about circularity and circular models, etc. The products which we make can be recycled, and can be recycled not only 5 times or 10 times, but we can recycle much more, because we don't actually melt the plastics. We make them warm and soft, and then we process it and mix it. Therefore the molecules are not hurt as much as in a normal recycling process of plastics. So what are we doing? We are a startup company. We have a big ambition. We are currently based in the north of the Netherlands, in Eemshaven, in Groningen. And that's also where we want to set up our first production facility, where we want to process between 10 and 15,000 tons of 15,000 tons per year in input material, which means as well that we make so much construction material, so planks and poles mostly, out of it. We have a very regional approach, because we want to source locally, we want to manufacture locally, and we want to actually go into the market locally. So we have planned 4 factories in the Netherlands, and currently we're looking into funding those factories. We had a session last week with an engineering consultant to make the layout of the whole plastic, of the whole factory, to determine material flow through it, etc., etc. So we hope that in the first half of next year we have our first factory in the northern part of the Netherlands ready and operating. We have something to do with wind turbine blades, because you can see them there on the picture. We're based in with our test and demonstration facility, where you see a picture of it here. We're based in that building where the white arrow points at. And that's in the midst of an area where a lot of wind turbine blades are being stored for commissioning and maybe later on decommissioning as well. And this is also potentially a site where we will build our factory, but we've not finished our location search yet in the northern part of the Netherlands. Here we have to build a new factory, and as ports are struggling with space, but also all sorts of permits and licenses to build a new building in the Netherlands is currently very complicated. We are also very interested in the northern part of the Netherlands to move into an existing building, because that saves a lot of time and a lot of permits at this moment in time. But this is where we hope to be operating. A little bit more about the technology. This is the investor where I spoke about. Actually, we put on top of this machine, we put the material in, preferably baled. It's pressed with pressure to the middle of the whole machine from 2 sides, and there's a rotor with holes in it. And because of the friction, it warms up, and because of the pressure, as it becomes soft enough, it will go through the holes in the rotor, and then it's going into an extruder, and the extruder will push it basically into the mold, and then we release it. And this is quite a unique process, because normally you cannot mix different types of plastics very well together. You cannot melt them together because you work at one temperature, and we basically don't melt the plastic, but we make it all of the same plasticity, or how you call it. And at that moment, when it's soft, it starts to turn around this rotor, which is turning in the middle, and then it's pressed and mixed together when it's soft, and apparently that works quite well, because we get quite a nice material out of it, which we can use. What can we make of it? Planks, poles, all sorts of shapes. The climate tree, as we call it, for places in urban areas where it's difficult to grow trees because there's cables in the ground, or a parking garage or something else. You can put a structure on of this plastic, for example. And that was basically how we came to using wind turbine blades as well, because this shape of tree with plastic, if you put it in the sun, probably the branches will touch the ground after 2 days, because plastic is quite soft. But we can also, at a certain moment, put the shape which we cut out of the wind turbine blades inside them. And I will come back to that later. Or we can reinforce the plastic with shredded or milled wind turbine blades with the fibers out of it. In the past year, we've done a few pilots. One with festival camping waste from Lowlands. That's a big music festival in the Netherlands, where people will stay in little pop-up tents, etc. After 3 days partying and high on the party drugs or alcohol or whatever, they walk away and leave behind all their tents, sometimes clothes, mattresses, etc. We took a container full of that waste, and we brought it to our Eemshaven. We sorted it into 2 sections. One we could use, and the other one we could not use. And we can recycle about 70% of the waste left behind at the festival. The festival said, well, we asked the festival, what would you like to have made from your waste? And they said planks and poles. And I said, oh, that's good, because that's exactly what we can make. And they will make benches or fences or walking paths out of the planks, which we can supply to them. We're also working with a number of hospitals in the Netherlands, because hospital waste, every little scissor or whatever is packed in 3 types of plastic. Very clean plastic, for us a very beautiful source of material. But most of the waste from the hospitals currently is being burned directly into incineration. And then the last thing we did was we took some port waste from the Eemshaven, from Delfzijl, or ship waste from ships which were coming to that area, or even from the Wadden Sea. We took some plastic waste which was catch there, and we're going to make girders, fenders for the keys for them for a pilot project. And that's also a material which can be very tough. And also there's a possibility to mix wind turbine blade fibers into the material to make them stronger and harder and more durable. And these are 3 projects which we did, and especially on those 2 we can use different materials. Last time, and I think that somebody mentioned it already, also the shredded material from wind turbine blades have a very good insulation value, so you can use them also in sandwich panels which we made from our material. That's the first one. The second one is basically to say, okay, we use the fibers as a reinforcement in our material to make them stronger, the planks, poles or beams. And the third one is to cut out shapes, because we are developing currently a different process without the extruder on our process to actually fill the molds. And that's more like what you do with concrete. If you have you pour it on the floor, we pour it in the mold, which is an open mold, and then we shake it a little bit so that all the air and gases go out, and then we cool it and we take it out. And in that process, it's very easy to put, for example, the shape which you cut out of the wind turbine blade inside the mold into your form or shape, for example, of the tree, and the branches will not go to the floor, but will stay in the shape in which you have designed the mold. So those are the opportunities which we have, which is recycling, but we try as well to put them into the market in a circular concept, because everything is recyclable, but you can only make it circular if you take also the product back for recycling. So with the last solution, for example, we have to take care that if you make something like that if you take the product back at the end of their life, that we can take the wind turbine blade out again and reuse it again, or separate it at least from the plastic material which we put in there. So those are the solutions which we have. I didn't use my 32 slides, and I think that everybody wants to network still a little bit. So I would like to thank you for your attention.
Thank you, Jan. Any questions for anyone? Question? You have?
You put the plastic product into the environment for a large degree. How sealed is it? Because there's wear and tear, and there's nanoplastics.
Mm-hmm. Normally, if you use a lot of the soft plastics, LDPEs, etc., it is sealing quite well. So also the organic waste which is still in there, etc., will not leach out a lot, I must say. It is rather insignificant. Nanoplastics, normally if you put a beam in the water, even in the salt water, nothing will happen to it. Only if a ship hits it, you will get some pieces of plastic off it. If you drill a hole in it, you should not do that above the water, because then you will get all the small material in the water. And so that sort of processes, sawing, and because you can treat it like wood, you have to do that in a controlled environment and make sure that you catch all the materials that come off it. Nanoplastics is a very small, or actually doesn't really exist. It's much more if you put your clothes in a washing machine, then you will get the small plastics off a lot. But it will not degenerate, and that's also because there is some UV protection. Because normally the plastic will degenerate easily into the sunlight. And that happens quite fast. That is something where you get the nanoplastics from. If you put the right UV protection in your material, and a lot of material consists of UV protection, it will not degenerate too much. I can't say that nothing will happen, but very little will happen. But we have to prove this as well, because you can believe me or not, but so we are testing most of the input streams which we have, so the recipes which we make, and we will test that in the Circular Plastics Labs in Emmen of NHL Ostend on characteristics, but also on leaching out and those sort of things.
Any more questions? No? Okay. This was our closing speech. Thank you very much. I still would like to draw your attention to that man over there, because it's a true artist in what he's doing the whole way. Thank you, so. I saw a lot of people making pictures of all the drawings you've been making. Maybe tell the people a few things, how you experienced the conference.
Accurate. I think it was very interesting, a very meaningful topic, I would say. That's one of the perks of my job, is I get to do all sorts of environments. So maybe let's have a look at what we've co-created, because it's your content that went through my head, then into my hand, and then on the board. So I think I will not go into detail. I wouldn't be able to. I think we started here with the opening of the conference, all about eco-innovative concepts for decommissioning and repowering offshore wind farms. So we talked about the why, the transnational collaboration, the cultural issues and challenges that we have around there. And that helped me out here. I don't know which one was the second one. Was it immediately the panel? It doesn't matter. So we talked about the first panel conversation, dove a bit deeper into the challenges and opportunities and how we can accelerate all that thinking together, sharing best practices and all that kind of stuff. We looked at the European perspective, the environment perspective, but also the business perspective, and the use cases related to that. And then I think we dove into more challenges and opportunities, and then we had some presentations from the universities and some companies, Western Norway University, University of Aberdeen, with their decision support system. That was a challenging one to draw. We had Advantis talking, and then we had some questions and answers before going to lunch. And then afternoon we went, I think on that side, so over here, end of life of offshore wind turbine. Now I know what OWT means. And the end of life planning related to that by the University of Ostend. Talking about the uncertainties that you have to deal with across the supply chain. We talked about the port logistics with the port of Grena, the gate to Kattegat. I understand that, it's the same as in Dutch. And how wind is extremely important to that port. But also how they deal with recycling and waste management and sharing some of their strategies around that. It's very interesting. And then we had the port of Ostend, talking about the importance of wind and offshore in their environment. And then also Renus Logistic, talking a bit more about the logistical challenges of offshore wind parks, specifically with relation to decommissioning. And I now also know what a jack-up vessel is. I saw the picture, so I hope I got that right. And then we looked at the presentation of Echt around the problems of recycling to do with the EU Waste Directive, and that it should be changed, the narrative should be changed, and maybe also the tender criteria should be different to have more impact. We looked at the pyrolysis, or pyrolysis, I don't know how to pronounce that. I know my oven has a function like that, I don't know if it's the same. So there's also no oxygen involved. And how we can substitute virgin fossils, or virgin fossil oils. And then we looked at complete material and energy recovery by Jewelmine. I really liked that presentation on carbonate circularity. And I think we finished here with these two blade-made scalable repurposing, climbing walls, sound barriers, lots of really nice pictures that I could work with. Thank you for that, wherever you are.
Nice climate tree too.
Yeah, absolutely, and then the climate tree to finish. And of course I was inspired by the unwaster, and I drew him here, but had a bit of a problem because what comes in has to come out, so and it has to be clean, so I was a bit stuck with that visual. It goes to show that the metaphors can be tricky. So let's unwaste. I think that was a good summary for everything. Thank you.
Let's have another drink and enjoy the moments together. Thank you.
Ja, dat is het grote probleem. De ruimte is niet zo. We hebben alles. Ruimte gecreëerd door naar de minimum helpen heel er was vroeger was een innovation pavilion, dan hadden we dat En huur. Dus dat is bij ons wel centrum zelf. Dus wij huren. En dan wel als centrum. Alles is eigenlijk van het en design lag op met dus wij hebben vandaag die stond in de executie. Dus de bouw die is niet op heel ja, maar die is toch zo. Die combinatie wel, uiteindelijk, dus één bedrijf, zwarte bedrijf dat is. De andere zijn dan rechts en de relaties. En dan de relaties in de tafel. Dat is wel eens gewoon in de MIA en haar team wat die mogelijkheden zijn.